In this video, I'm going to go over a few different types of scenarios where there will not be an actual word to be used for your equations. So I'll just go and make a couple of numbers here, and there we go. Got myself a couple of numbers there. Now, let's just say these right here are the price, and this right over here is the tax. And let me just go and say, make those percentages, and I'll say 3%, no, not 300%, that's right. That's right, David. You want 0.03 to get okay, 3%, there we go. I want a percentage, but okay. 10%. Now let's do a 0.3 for 30%. And let's do a 0.24 for 24%. And you know what? Let's just give it a 0.07 for 7%. There we go. So I've got my percentages lined up. And we have ourselves a total. Now, obviously, if I have these guys as dollar amounts, these guys as percentages, I could always just say equal this guy times this guy to figure out what 3% of it is. And that'll give me a 4.59. Oh, okay, well that's the price of the tax, because obviously 4.59 is 3% of 153. But that's not really what I was asking when I said total. So what I found out was I found out what 3% was, but I didn't find out what 3% added on to this 153 is. So this number right here doesn't really make much sense. I mean, I'd love to pay only $4.59 for a $153 item, but chances are that's not how it's actually gonna work in the real life. So, if something looks wrong, it probably is. Now, there's many ways to figure this out. I mean, we could try a plus here, and, well, that just gave me 153 and 3 cents. Okay, that's obviously not it. We need to go back to multiplication. Now, I could do this guy plus 1, because 1 in decimal format is 100%. So that should give me 153 plus the 4.59 and give us that. That'll work. So this is possibly a good answer. Or if I wanted to, I could do times this, and then plus my original number back in, and it'll get me the same exact result. Drag that down, and it'll give us, there we go, that plus that plus that, so on and so forth. Once again, if I switch it back to the other way I had it, times, let me put a parentheses there first, this times that, and it'll wind up getting the, whoops, not times 1, I wanted plus 1. And it'll give us back to the same correct answer we had before. There's stuff that you can wind up having like that. Or maybe these were, years, and I want to have a percentage change. Okay, so let's just say I'm going from this year to this year. I want to see how much of a change that was. Well, I could obviously do, current year divided by previous year. That'll give me, let's switch these to a percentage here. Boop! 333%. Well, that is saying that 10 is 333% of 3. But I'm not looking for how much of a percentage 10 is of 3. I'm looking for how much that percent changed. So really what I'm looking for, I need to subtract 100. And really I got it's 233% change. And if I, do the same thing across down here, 30% is 200% more than 10%, which makes sense. That seems valid, so that means this equation is working right. 24% is negative 20% of 30%. Okay, that makes sense, so on and so forth. You can wind up having to just make equations up that fit the thing you need. And the one example I use of this most often is that of weighted averages. So we know how an average works with, equal, average, and we grab our averages, and it gives us that number right there. However, that's assuming that every single one of these things is weighted equally. Now, here's the reality in the real world. Businesses do not care, really, about what happened 40 years ago. There's a completely different person in charge, they're under a completely different business plan, so on and so forth. So we take a look at this right here. The stuff that happened in 2016, that doesn't matter. The stuff that happened in 2017, that matters a bit more, matters a bit more, matters a bit more, so on and so forth. I mean, the stuff that happened right now, pandemic-wise and all that, I mean, that's more important than the stuff that happened in 2016. So, here we are. So, these are not weighted all equally with a 1 and a 1 here, 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 and I had my computer freeze, so it did that little thing there. What exactly are you? Oh, yeah, there we go. I just got messages from my phone, that's all. Let me stop that from getting on the screen. There we go. So, anyway, now that that's not going to interrupt us anymore, normal weighting, normal averaging, is assuming that all these numbers all have an equal weight, so they're all equal to 1. So the way we normally wind up doing that is something like, equals this plus this plus this plus this plus this plus this. And then we divide that by the number of weights. So we have 1, 2, 3, 4, 5, 6. So we have 6 weights, and we wind up getting the exact same number. I mean, obviously I didn't actually have this, have decimal points on it, but now it has decimal points, and they're the exact same number. Weighted averages are different. You may have seen weighted averages in your grades at some point in one of your classes, where quizzes are 30%, the final is 20%, however much percentage it is. And what that says is that these weights down here are now different. So I'm gonna keep the 2016 as a 1. I'm just gonna keep this simple as a demonstration. But 2017 is worth 2. 2018 is now worth 3. I just keep increasing my weights by 1 every single time we get, close to something. So boom. So now I can't actually do this equation of equal these guys divided by that. I instead will have to do, let me just copy and paste. Oops. Once again, remember that that references change with the cell, so I should have used absolutes. So now instead of using 6, I have to divide this by the number of weights. So let's see, 1 plus 2 is 3, 3 plus 3 is 6, 10, 15, 21. I have 21 weights right here because the triangular number of 6 is 21. I have 21 weights. Boom! And that is actually, once again, as I said before, if something looks wrong, it probably is wrong. How can all these numbers that have the smallest amount being 457,000 have an average of 206,000? Well, that's because this right here is not the complete equation. Okay? Think of it like this. We have ourselves, and this is where it'll try to color code parentheses for you so it understands. I did say parentheses would come in handy. This cell is being multiplied by that cell because that's how many weights it is. Or I could just say it's being multiplied by 6. Plus this cell, use it, remember your parentheses, this cell is being multiplied by this cell because that's the weights. Or we could just say 5 plus, and I believe you'll see what's happening here. Boom, this guy times 4, because that's worth 4 weights, plus this guy times 3 weights, plus this guy times 2 weights. And if you really wanted to say this, you could say this guy times 1, but times 1 is just itself, so we'll just leave it as itself. And this is where, once again, order of operations matter. You may notice that it has been giving me these red parentheses. Well, that's because here's the start of that chunk, here's the start of that chunk, here's the start of that chunk. If I leave it just like this, with this G2 divided by 21, because of the order of operations, the only thing getting divided by G2 is the 21, which will give me this, bizarre formula that gives me somehow 15 million. Once again, if it looks wrong, it probably is. So, what I need to do is I need to close that out. So now we look at it. The entire numerator is all cobbled together first, with all its little individual steps inside, making sure that the most common weight, the most important weight is weighted by the most big number, the second one by the second most, third by third most, so on and so forth. Making sure all of that is done first before we divide by 21. And now you'll wind up with a 754,270, so on and so forth. And that right there makes a lot more sense than the previous numbers I was getting. Now, if you look at an equation like this and go and say, oh my, that is a little bit overkill. Well, I do have good news for you, because let me just go into Google Sheets here and just give a couple of numbers here. I don't know, you guys are that, you guys are that, you guys are that, you guys are that, and you guys are that. And I don't know, you're a 1, you're a 2, you're a 3, you're a 4, you're a 5. So here's our numbers, and here's our weights. I have an equation here. It's called equal average dot weighted. And this only exists in Google Sheets. I have to grab my numbers first, comma, and then grab my weights. And it will automatically attach the first number to the first weight, second number to the second weight, third number to the third weight, so on and so forth. And I wind up getting this number, which is different than if I simply did equal average, and I just grabbed those numbers and had it weighed evenly, in which case gave me a 158.4. These numbers are different because they're different equations. This has a dot weighted option, and it requires just the numbers and then the weights. Now, there is no such thing, as of right now, of doing equal average dot weighted. Doesn't exist. I can try it all I want. I can try grabbing this, comma, and then grabbing my weights. It does not exist in Microsoft Excel as of right now. And even if I try to do equal W for weights, I get weekday, weeknum, Weibull distribution, workday, workday international, and, Weibull again. So, nope, there is no such thing as a weighted average. And even if I try equal average, I got average, average dev, average A, average if, and D average. So, nope, there is no weighted average function as of right now in Excel. So if you're using Excel, you have to make a weighted average by hand. And of course, once again, I just picked 6, 5, 4, 3, 2, and 1. I mean, I could have made this, 30%, 20%, 15%, 17.5%. It doesn't matter. I could have made it whatever it is I wanted. I just picked simple numbers just for the sake of demonstration purposes. But, point being, you will have to be able to use mathematics in order to create certain equations to your liking, because not every single answer you have is going to be up here in the Formulas tab available for you to use. Okay? And that's even counting with all the 700 bajillion statistical and trigonomics and all the other things that they have in here. Not every single thing is going to be able to be done for you just with a simple word and equation. You are still having to use mathematics. Coding is math. It is a lot of math. Anything involving computers is math. So, hence if you were wondering why there was a math requirement before taking this course, that would be why. And we will be getting more into mathematics and equations as we go into line-by-line coding in the, subsequent languages. But just giving you a little taste of it right here. So, if you're confused, I recommend you go back in, rewatch the video, stop, pause it if you need to, type things out, and start following along in the videos. Speaking of which, the next video will be a follow-along assignment where I will be typing in manually certain types of equations. So, thank you very much. You guys have a great day, and I'll see you in the next video.